Welcome to the Explainer. Today, we are pulling back the curtain on one of Python's most common features, the for loop. We use it all the time, but we're going to uncover the hidden magic that really makes it tick.
So let's start with something that is probably just pure muscle memory for anybody who's written a line of Python. You've typed it out 1,000 times, but have you ever stopped to think about what's really going on under the hood? You see this on the screen for item in my list, and it just makes sense, right? It's clean, it feels super intuitive. You just, grabbing items from a list one by one. But how does Python actually do that?
And that's where it gets really interesting. How can this one simple for loop be such a jack of all trades? It works on lists, sure, but also strings, files. It can even handle data streams that might go on forever. How does it do all of that? Well, that is the secret we are going to unlock today.
Okay, the answer lies in this really elegant design pattern called the Iterator Protocol. It's the engine running everything, and to understand it, we need to meet the two main stars of the show.
So, on one side, you have the iterable. Think of this like a playlist of songs. It's the whole collection, something you can loop over, like a list or a string. Then, on the other side, you have the iterator. This is the actual music player. It's the thing that serves up the songs one by one and remembers which one to play next.
So here's the key thing about an iterable. Its only job is to have a special method called _iter. When you say, hey, I want to loop over you, the iterable uses that method to just hand you back an iterator. That's it. That's its whole job in this relationship.
Now the iterator, that's the real worker bee here. It's the one doing the heavy lifting with its own special method called _next. Every single time you call next on it, it coughs up the next item in the sequence, and importantly, it remembers where it left off. It's the one keeping track of the state.
But, what happens when the playlist ends, when there are no more songs to play? Well, it doesn't just blow up. Instead, it raises a special signal called stop iteration. And you can think of that as its way of politely saying, hey, we're all done here, nothing left to see.
Okay, so we've met the iterable and the iterator. Let's put it all together and see how they power that simple for loop. This is really the aha moment.
So when Python sees your code for item in my list, it's not some weird magic. It's really just a convenient shortcut for this three-step dance. First, it calls iter on your list to get the iterator, the music player. Then, in a hidden loop, it just keeps calling next on that iterator to get each item. And all the while, it's listening for that stop iteration signal. The second it hears it, it knows the party's over, and it exits the loop, nice and clean.
And that's what makes this design so brilliant. The for loop itself doesn't have to know anything about what it's looping through. Is it a list, a string, some complicated object reading from a network? It just doesn't care. As long as the object you give it follows this protocol, as long as it can hand over an iterator, the for loop just works.
So you might be thinking, okay, that's a cool little detail, but why should I care? How does this actually affect the code I write? Well, this is where this little protocol goes from being a neat piece of trivia to being an absolute superpower for your code.
Just imagine you need to process a log file. And it's a big one. Let's say it's 10 gigabytes.
So what do? If you tried to read that entire 10 gig file into a list in your memory, your computer would probably just give up. You'd run out of RAM and the whole thing would crash. So how do you possibly process every single line in that massive file?
The answer is laziness. And in programming, lazy is a really, really good thing. The Iterator Protocol is what makes this possible. You see, file objects in Python are iterators by their very nature. So when you loop over a file, Python isn't reading all 10 gigs at once. Nope, it just reads one single line, hands it to you, and then patiently waits for you to ask for the next one.
This lazy approach is what gives us these incredible benefits. You get super low memory usage, since only one item is ever in memory at a time. That lets you process huge data sets, way bigger than your available RAM. You can even create things like infinite sequences, maybe from a sensor that's always sending data. It all adds up to code that is way more efficient and scalable, and it's the foundation for pretty much all serious data processing in Python.
So now that you know the secret, you don't have to just be a user of this protocol. You can actually become the magician yourself and start building your own custom sequences.
And the recipe for doing this is surprisingly simple. All you have to do is create a class, and then you just implement those two special methods we talked about, _iter and _next. You handle the logic for what the next item is, manage some kind of internal state, like a counter, and just remember to raise stop iteration when you're all done. That's it.
With that simple pattern, you can define literally any sequence you can dream up.
Take a look at this simple countdown class. It's a perfect example. The init method just sets up the starting number, iter just returns self because this object is its own iterator, and all the logic is right there in next. It checks if the countdown is finished, and if not, it ticks the counter down by 1 and returns the number. And just like that, you can now write for number in countdown 5, and it works perfectly, just like it was a built-in part of Python.
And this is why creating your own iterators is so incredibly powerful. You can now define sequences that are calculated on the fly. Maybe each item takes a ton of computation to figure out, or maybe the full sequence would be too gigantic to ever fit in memory. With a custom iterator, you only pay the price, in time or memory, for the items you actually use, right when you need them.
So the next time you write a simple for loop, you'll know. You'll know about this elegant, powerful, and incredibly efficient protocol that's working hard for you behind the scenes. And that really leaves us with a final thought to chew on. What other hidden protocols are out there, hiding in plain sight in the code you write every single day?